In sections 11.2 and 11.3, we are going to study two specific types of sequences in series. In this section 11.2, we will study arithmetic sequences in series, and then in 11.3, we will turn our attention to geometric sequences in series. So let's get started with section 11.2, which again is arithmetic sequences in series. So the first thing we're going to do is talk about what an arithmetic sequence is. So if you read the bullet point there, it says an arithmetic sequence is a sequence in which each term after the first differs from the preceding term by a fixed constant called the common difference. All right, so let me give you an example of an arithmetic sequence. Let's say I have the numbers -3, 1, 5, 9, 13, and so on. Okay, this is an example of an arithmetic sequence. Okay, why? Because when you go from one term to the next, you always get there by adding the same quantity. So to go from -3 to 1, I have to add 4. And then to go from 1 to 5, I add 4. And then to go from 5 to 9, I add 4. And then from 9 to go from 9 to 13, again, I add 4. And then the dot, dot, dot assumes that we will continue this trend of adding 4 every time to get the next term. Okay, so that's what an arithmetic sequence is. Okay, again, each term after the first differs from the preceding term by a fixed constant. Okay, so in this particular situation, this +4 that we're adding every single time, that is called the common difference. Okay, so here the common difference is 4, +4. Okay, we denote it with a lowercase d. Okay, so you could be subtracting. Okay, you don't always have to be adding with an arithmetic sequence. You can be subtracting a quantity to go from one term to the next, and then your d value would be negative because you would be adding a negative number essentially. Okay, all right, so below this, you'll see the formal definition for common difference. It says if the common difference of an arithmetic sequence is d, then for every positive integer n in the domain of the sequence, we can calculate the common difference d by taking an plus 1 and subtracting an. Okay, so this is a formula you can get or a formula you can use to calculate the common difference, and all it's saying is if you have the nth term, that's an, then an plus 1, that's going to be the term that comes after an. So to come up with your common difference, you're just going to take a term, and subtract the one that came before it. Okay, and that should give you the common difference. Okay, so let's take a look at example 1 here. Okay, it says determine the common difference d for the arithmetic sequence 20, 13, 6, -1, -8, and so on. Okay, so again, all you have to do is look at a pair of terms and figure out how you go from the one to the next. Okay, so to go from 20 to 13, I have to subtract 7. Okay, and that trend holds. To go from 13 to 6, I subtract 7. To go from 6 to -1, I subtract 7. To go from -1 to 8, I subtract 7. So my common difference here is -7. Okay, that's it. We can just recognize it by looking at pairs of terms. Okay, if you wanted to use the formal definition, okay, where it says, pick a term and then subtract the one that came before it. Okay, if you know your sequence is arithmetic, it doesn't matter which term you pick. Okay, so if I pick 6, if I wanted to calculate it with a pair of numbers here, a pair of terms, I would just pick a term 6 and then I'd have to subtract the one that came before it. Okay, so the term that comes before 6 is 13. Okay, and so that's another way you could calculate the common difference. Okay, all right. In example 2, okay, we have a couple of parts here. It says find the first 5 terms of each arithmetic sequence. Okay, so in part A, we're told the first term is -14, and then the common difference is 6. Okay, so based on this description, we can easily generate the first 5 terms. So A1, the first term, that's given. It's -14. Okay, so then to get the second term, A2, we need to take the first term and then just add the common difference. The common difference is 6. It's positive, so we're adding it. -14 plus 6 is going to give us -8. So A2 is -8. Okay, to get A3, you're going to take A2 and then add the common difference, okay, which is 6. So that's going to give us -2, okay, and then just continuing in this fashion to get A4, I need to pick up where I left off with A3, which is -2, add the common difference of 6, that's going to give me 4, and then to get the fifth term here, we need to pick up with A4, that's 4, add the common difference of 6, we get 10. Okay, so the first 5 terms here, I'll write them in red: -14, -8, -2, 4, and 10, and this trend should continue. Okay, at the top of page 2, let's look at example 2b. Okay, so this time we are told, we're operating under the assumption that we are dealing with an arithmetic sequence, okay, but we're told that A1 is 3 minus the square root of 2, and then A2 is 3, okay. Remember, we're asked to find the first 5 terms of this arithmetic sequence. Well, we already know A1 and A2, okay, so I'm just going to jot these guys down again. Okay, so A1 is 3 minus the square root of 2, A2 is 3, okay? So then we need to calculate A3, A4, and A5, okay? Well, we're told that this is an arithmetic sequence, okay? So what we can do, since A1 and A2 are terms right next to each other, we can figure out the common difference from these two guys, okay? So if I take A2 and subtract the term that comes before it, which is A1, that will give me the common difference, okay? So A2 is 3, and then I'm going to subtract A1. Okay, now A1's kind of a crazy number because you've got the square root in there, but 3 minus square root of 2 is a number itself. We're going to subtract the whole thing. Be careful here. You need to subtract the entire quantity. You're going to have to distribute this negative here to get it, to make sure you do it right, okay? So we'll get 3 minus 3, and then minus a minus will become positive. Okay, so we learn from this little exercise that the common difference is the square root of 2. It's a positive number, okay? So this is what we're going to have to add each time, okay? So to get the third term in the sequence here, we're going to take A2, which is 3, and we're going to add the common difference, which is the square root of 2. We're done, okay? There's no way you can further simplify this number. Don't jump to the decimal, okay? It's much cleaner to use exact answers, okay? To get the fourth term, A4, we're going to take A3, which is 3 plus the square root of 2, and then we're going to add the common difference again, which is the square root of 2, okay? So to simplify this, we can combine like terms. We can combine the radicals. So we're going to leave the 3 and then add, we have 2 instances of the square root of 2. So this is going to be 3 plus 2 square root of 2. All right. And then to get the last term here, A5, okay, we're going to take A4, which is 3 plus 2 square root of 2, and we're going to add another instance of the common difference. Okay, so tack on another square root of 2 and combine like terms. Okay, the 3 doesn't have a radical, so we'll leave it by itself, and then we're adding Here we have two instances of the square root of 2, and then here we have another instance of it. So we have a total of 3 square roots of 2. So the fifth term here is going to be 3 plus 3 square root of 2. Okay, so those are your first 5 terms. I'll go ahead and summarize in red above here, above the problem itself. So our first 5 terms are going to be 3 minus the square root of 2, 3, 3 plus the square root of 2, 3 plus 2 square root of 2, and then 3 plus 3 square root of 2. And this trend should continue.